Okay, in this video we're going to go over the hierarchy of levels in a computer. I'm going to start with level 6, executable programs. Anyone who ever uses a computer is going to be familiar with level 6. Those are applications and compiled programs. Below that is high-level languages like Java and Fortran and C++. So we created instructions out of a high-level language to create those apps. And as computer science students, we are very familiar with these. Those high-level languages are compiled into assembly code. So this is the lowest form before having to deal with ones and zeros. Because from assembler language, it's converted to machine language. And so also as computer science students, you should have already had some introduction to assembly language. The next level below that is system software. And again, that should have been a prerequisite for this class. You should have already had a class in system software. It controls the executing processes on the systems. It controls the operating system software, controls execution, input-output devices. This class, we're going to talk about levels 2, 1, and 0. So level 2 is machine code, also known as instruction set architecture. And they consist of instructions that are particular to the architecture of the machine. Level 1, control level. That's a control unit. It decodes and executes instructions and moves data through the system. We're going to talk about microprogramming, and that's done at this level. Or it can be hardwired. The very bottom, digital logic. This is where we deal with ones and zeros. We get down to gates, transistors, ones and zeros. So looking at what happens when a user uses a program, at the top, they use their executable program, their word processor. That word processor or program was put together with a high-level language, compiled into assembly language, controlled by an operating system. All those assembly language instructions were turned into simple instructions like add the contents of 2 registers, very basic machine language. That machine language is controlled using a control unit that consists of things like adders. And those things like adders are put together with gates and circuits. So this picture down here, you put together a number of these objects to make a thing that's an adder, and we'll talk about that in this class, how those are put together. So let's look in a little more detail at the bottom 3 levels, which is the focus of this class. Level 2, instruction set architecture. In this class, we're going to use MIPS throughout the class as the instruction set architecture we'll use for all of our examples. Here's an instruction. Take the contents of register 1 and the contents of register 2, add them together and put them in register 3. That's carried out at level 1, the microarchitecture, where the contents of register 1 and the contents of register 2 are passed to an adder, and the result from that adder is put back into register 2. This level, the microarchitecture, is built using level 0 digital logic, which would be gates. Transistors are basically on-off switches. So they're used to carry out ones or zeros. Gates take one or more inputs and produce an output. So an AND gate would take 2 inputs. If both are 1 or on, the result is 1 or on, and so on. So we're going to talk about AND and OR gates, which you might already have some experience with. Or if either one of the inputs are high or 1, the result is on. So instruction set architecture, we start going over in Module 3, and then it's used throughout the class. We talk about gates in Module 3. We talk about the control, the arithmetic logic unit, control unit, and microprogramming in Modules 2 and 4. So all of these ideas will be introduced in the next few weeks and then used throughout the class. So that's a good introduction to what this class is all about. It's these bottom 3 levels. So have fun.